Andreas, the floor is yours.
Thank you very much, Daniel. Welcome, everybody. Today we heard a little bit already about deployments and running AIs and things. All of this needs to be tested, and today I'm going to talk a little about something a little bit different. It's not about SIP, actually. It's beyond SIP. It's about how to build a testbed for mobile cars on a budget. And that means we're going to play a little bit with real mobile phones. It's me again, Andreas. I'm in this community, as Daniel said, like for, 20 years. 15 years ago, we started RTP engine at Zipwise, and I had the pleasure, although I didn't do a lot of coding, but to lead the project. So Richard Fuchs was doing the hard work. I was just taking the credits. Since 5 years, I'm focusing on SIP testing or on telco testing in general at Sipfront. And the reason for that was that over my, 20 years of doing SIP development, I always lacked like proper tools and things went south a lot. And this is where I took the challenge, and it's something that I'm going to talk about today. So I'm so looking forward to go through the Excel test plan again. This is what we all look forward to after, like Jonas said, upgrading 80 Kamailios at 3 in the night, right? And then you're like, okay, I'm done. Am I free to go? And you're like, no, I have the test plan to work through. And yeah, there are different kind of people, but I know very few that actually would, sign this statement. And the problem about this is what's happening if you don't. Like last week, we had again a major outage in Austria. Mobile carrier had an issue with data, and also telephony was partially affected. And a funny or not so funny thing is, again, a technical infirmity after maintenance work. And that happens all the time, right? Now, the thing is, we know a lot of people in this industry and with these telcos, and if you talk to them and say, hey, you actually need to test more, and they're like, yeah, but I can't possibly test like 100 cases in 2 hours, right? And that's what's happening. So if you upgrade your SBCs, you do 1 or 2 test cores. I don't know how many times I started blowing into the phones and check if I have two-way audio over the past 20 years. And that's what's being done. Right? And what you really want to do is you want to turn these 100 tests in 2 hours into, hey, let's have 1,000 cases, go for a coffee, right? And once we are back, we want to see the green check or like a red cross. And if it's the red cross, then it's not 7 in the morning and we are like, okay, the customers are starting to, pick up cars, rather than it's still 3:15. And we have a couple of hours to think about the rollback, right, or roll forward, or whatever the decision is that we can do. But the good thing about this is then we have the time to do it, and we also have like the scope of, is it just this particular feature that's not working, and okay, you can do it next night, or is it something really important for this really important VIP customers that we have, and we have to roll back like all of that. And the only way to solve this is test automation. You really got to automate these kind of cores. And this is what we're going to talk about today. I've done some presentations in the previous Kamailio words about automating SIP cores. Sometimes you want to go a little bit higher, actually, and test with, for instance, actual mobile phones or mobile devices, because, yeah, you can do talk VoLTE to your VoIP infrastructure, for instance, directly. But you have the peculiarities of an iPhone working slightly different than a Samsung Galaxy S from a VoLTE stack perspective. So you really want to use the end devices that the users use. And you can use SIM boxes for that, right? Like there are great products out there, mostly based even on asterisk, I think. So you have modems in there. You can talk SIP to them, and then they just do a mobile call. That's nice, but again, sometimes you want to have like the real mobile phones because customers say, yeah, but it's still this particular feature doesn't work with these particular phones, right? And in order to automate this kind of devices, there are a couple of tools out there. They are also really great, like Appium, ADP, and Source Copy, and whatever you can use in order to, automate your the usage and the control of your phones. But I don't know if you have recognized that. It's really hard, particularly with native mobile cores and the native dialer, to inject and record the audio. Why is this important? Because if you do this end-to-end testing, as I said, you're blowing into the phone on one side, you're checking, does it work on the other side? You really want to inject something, and you really want to record and check if it's there, right? If you have like an audio connection, particularly after some core scenarios that you did. And you might also want to check the core quality of that, right? So it doesn't help you if there is something, but it's completely distorted. Now, we were asking ourselves, okay, when we're going to approach this and we can't use Appium or ADP or whatever, we do this for voice over IP apps and it works fine there, not so much for native dialers. So we were asking ourselves, what else is actually controlling your mobile phones? And the answer was actually quite simple. This guy is, for instance, right? Every time you step into your car and you have your phone connected to the car, you can actually, with your steering wheel, answer your calls, place calls, do kind of like navigate through your address book, and so on and so forth. Now, the thing is, how does the car actually do that? Pretty simple, by Bluetooth, right? So you have your car, you have your phone, you pair your phone with your car, and use hands-free, because it's mandated, at least in Europe, right? You're not allowed to take your phone while you drive, right, and place calls. Yeah? So you have to have this supported. Now, if you're at 3 in the morning and you did all your SPC changes, it's probably not so handy to come with your car and do your tests. So you gotta modify that a little bit, and you can actually put your Raspberry Pi in kind of like an existential crisis and have it pretend to be a car, because why not, right? And this is what we're going to look a little bit more in detail, like how could you actually make any Linux system, but particularly like a Raspberry Pi, into a device that pretends to be a car implementing hands-free profile. Now, how does this actually work with Bluetooth? So a very quick primer. There are a couple of Bluetooth profiles that are being used in different kind of scenarios. The first two, A2DP and AVRCP, they are really what you want to use when you listen to audio, like music, on your headphones, right? Because it's a one-way HD stereo audio streaming, and it has a kind of great audio quality, right? It's getting better. You can also remote control it, but that's one way. It's high definition, so you can't use it for mobile phones, obviously, because you want to hear what the other one is saying as well. So for this kind of scenarios, there are two other profiles. One is called headset profile, which is like a very simple profile. You have your headphones on, right? You get a call, you hear it ringing, and with like a press of a button on your headset, you can actually accept the call, for instance, right? Call quality is pretty poor for that, but it kind of works, right? But then there is an alternative to that, which is the hands-free profile. It's actually supposed to be used by cars with better audio. Now, what does it mean with better audio, right? There's a little bit of expectation management to be done for this kind of tests, because you are getting a phone call in, or you're placing a phone call, you have this additional radio connection from the phone via Bluetooth, and obviously there's some codec stuff going on, right? For handset profile, there used to be CVST and SPC. It's like 8 kilohertz and very low bandwidth. You get some G711 vibes with that. What you really want to look for is the MSPC codec, which is supported by HFP profiles. It's there since, I don't know, like 12, 15 years even. And it at least does 16 kilohertz mono at 16 kilobit per second, so which is kind of okay if you do your mobile calls via AMR wideband, for instance, right? Which falls into kind of the same category. But actually, this kind of test setup starts to be a limiting factor for AVS, for instance, right? So just keep that in mind if you want to do like audio testing. What you get, though, is like the basic functionality, like you can dial with your phone remotely via Bluetooth. You can answer the phone, you can do DTMF and so on. But it's the biggest nightmare for me all the time when somebody calls me, sorry, Oliver, it's nothing personal, but people are calling me saying, hey, can I talk to Oliver? And I'm like, damn, I need to do the transfer on my phone again, and I swear to God, every time the call drops, always, right? So I'm usually nowadays resort to, yeah, can you give me the email? I'm gonna send you the number and connect them directly. But that's actually like really a problem, and I'm pretty sure that it's not always me dropping the call on my phone when I try to do the transfer and stuff. So what HFP also supports is like the 4 apocalyptic riders, which is like hold and dial, hold and swap, conference and transfer, which is like the typical scenarios that you need like in P2P scenarios. You know, you are on a phone call, you get a call in, and you can actually remotely via Bluetooth hold and dial and do a second call, for instance, to ask Oliver if they're willing to do answer the call. You can then also swap the calls, check in between. You can then put your three-way conferences, like what we used to do like 15 years ago with SIP as well, right? And you can do the transfers, right? Now, how do we approach this? So you get a plenty of capabilities via Bluetooth to control your phone and also to get the audio in and out, right? So how does it actually work? So you need, obviously, a mobile phone with Bluetooth, but nowadays pretty much all of them can. So it doesn't matter if it's Android phones or an iPhone or even some Nokia feature phone if you still have them lying around. What you need on the Raspberry Pi is obviously Bluetooth daemon in order to communicate with the phone. And then you need 3 different elements to drive your phone via Bluetooth. One is getting the bearing up and running, right? So obviously you sit into your car and you say, hey, I want to connect my phone to the car, or in that case to my, Raspberry Pi. You need to get the audio in and out, right? So you have some kind of audio wiring that you need to do. And you need to have the phone signaling. So I want to, dial, and then once the call is up, I want to do a second call and a three-way conference. So how does this work? And we're going to look a little bit into the technical details of that. The way it actually works is pretty simple, right? So you have a couple of open source tools that are available in your Ubuntu and Debian systems out of the box. Look for newer versions, like, Ubuntu 2024. Particularly for the 2 elements in the middle, Pipewire and Wireplumber. They are like a kind of new audio framework in Linux. You have Ophono, which is a pretty ancient, actually, project from 2009 in order to drive your phones. And then you need to have some kind of, I call it like Sipfront Bluetooth agent, but we're going to look at how you can actually do that by yourself. And all of that is kind of glued together with a dbus system. Yeah? And let's look at what that means. So what's dbus? If you're using a Linux desktop, GNOME or KDE, you are actually using that already, right? Because it's a message bus. It's actually being used, or was supposed to be used for Linux desktops. What's happening is, right, if you plug in a hot plug audio or a wireless card or your network changes, you have this on the top right, the symbols showing like the signal strength of your Wi-Fi connection. You can control your volumes. All of this is actually being done by dbus, right? And if you connect like Ophono to dbus, you can actually also get or control and get events for calls, right? So that's how it's supposed to work. Now, what's Ophono? It's an open source mobile framework. It was invented by Intel and Nokia in 2009 by some, I don't know what the phone was called. Anyways, it's obsolete. Then it was used by Intel and Samsung in 2011 or 12, and then there was Sailfish US. So it's all like pretty old stuff. usually it was supposed to, build Linux-based phones, right? But since, Android took that all over, it actually got, I don't think it's being used in Android, to be honest, right? But it's still there, and it works, right? And it uses the dbus API in order to provide like remote functions, to do a call, to answer a call, to send TTMF, to do the transfers and stuff like that. And it comes with a bunch of scripts to provide you like example use cases for that, like dial number, for instance, right? It's a script readily available. If you pair your phone and you get Ophono to connect to it, right, you can actually just on your Raspberry Pi on the CLI, just say dial number 12345 and your phone will happily dial. Yeah. So Ophono is being used for doing the phone driving, and you don't actually have to configure anything. You just say apt-get install, and it kind of works, right? There's something you need to configure in Pipewire. And Pipewire and WirePlumber, they are some audio and video routing server. They are supposed to replace jack and pulse audio. It's gonna be complicated because audio in Linux has always been a mess. It's not getting any easier with that, but the good thing about that is that it really works well with Bluetooth D, and it also really works well with Ophono, right? So there's just one configuration option in some config file where you say, hey, if you do the Bluetooth connection to your phone, just hand it over to Ophono, and Ophono will then take care of, the audio routing, and it will create audio devices on your Linux machine, and that's about it. I think the only thing that you really need to configure is, you need to enable Ophono in some config file, and you need to tell it to use MSPC, like the codec we were talking about before, to really make sure that you have like not HD audio, but at least 16 kilohertz sampling rate, and not 8. Yeah. About the Bluetooth pairing, you are supposed basically to write a Python dbus script, or Python would be the easiest one. There are plenty of scenarios or examples on the internet or on GitHub. Because if you start connecting your phone via Bluetooth, you get in dbus a couple of events where it says, hey, there's a new phone. What do you want to do with that? And obviously, since you don't want to enter some pins and stuff when you do the coupling, you want to have a script that just automates all of that. You can do the same with Bluetooth CTL. Yeah? So if you run Bluetooth CTL and you connect your phone, you pair it with this device, right? You just say before, hey, power it on, you have an agent with no input and no output, so please no pin code stuff and so on. You make it discoverable, you make it pairable, and then you pair it on your phone, so it will appear on your mobile device as like kind of like a remote audio device. And you pair it, and then you say, hey, trust, and it's usually a MAC address, some Bluetooth MAC address, trust this device. And then Bluetooth daemon together with Ophono and WirePlumber and Pipewire will create audio devices and audio instances that you then can use. Now, there's just one word of caution here. Stay in the lane when you work with these kind of things. The thing I said before is dbus and WirePlumber and Pipewire, they are supposed to work on like Linux desktop with user sessions, right? So you log into the system as a user, and then you get like all these devices. Don't try to fight the system. I tried because I was like, hey, I don't want to have a user, I'm root, right? So try to do everything as root. Don't do that. It won't even allow it, and I tried to hack it out, but didn't succeed. You can't even start certain elements like Pipewire as root. It says in the systemd files, hey, you are root, denied, right? Tried to work around that, didn't really work, right? It was a waste of time. And the other thing is you just, you can configure your user. You have to configure your user on your Raspberry Pi, for instance, that when you boot it up, it auto logs into the system, creates the session dbus, and it just works. Yeah, don't try to fight it. You can if you're brave. Now, the whole picture. So how does it look like in the end? We have the mobile phone on the bottom with the Bluetooth connection. We have the session and system dbus as a glue. We have our tools like Ophono, Pipewire, WirePlumber, and your Bluetooth CTL or your own dbus script that just waits for the events for a phone to connect, right? You just pair it, and that's it. And then you have certain tools available in order to control that. So for instance, this dial number script I already mentioned, right? You just say, once the phone is there, you can say dial number 12345, and kind of magically your phone will come alive without being cabled or connected other than Bluetooth with your Raspberry Pi. And once the call is up, you get like these audio devices, and then you can use the pipe via, or I think it works even with the ALSA devices. So you have like audio devices that you can then use to say A play or PW play for pipe via, and you just, send from your Raspberry Pi a WAV file into the core, right? And you can, at the same time, you can also say PW record in order to record what's coming back in. So essentially, you have like a sound card there, and then you can start automating that. And that is exactly what we did at Sipfront. So wrapping it up from that perspective is, you have a call, you can configure your test case, you can just press run, and then it automatically dispatches a test to your Raspberry Pi, and it will connect to your phone, and then it will get all the events back, and you say, hey, the phone is attached, the call is incoming, it's established, and it ended remote, and stuff like that. And when you even get the like network information, like the signal strength and the network name, which is pretty important if you do like roaming tests, and you want to make sure that you're really in the right network. And then you can also do, when you, on the other hand, have like a SIP client, you measure all the RTP and RTP statistics. What you do not get out of the box is the signaling. So that's important. You don't get access to like VoLTE signaling directly, right? It's just like a very high-level way of working with the phone. Now, the interesting part is, so you're having that, you can create all your kind of test cases, you can automate all your mobile phones and your mobile cores and all the mobile scenarios. You can really verify automatically 100 times over if your call transfers actually work, or if it's really the user who is just too dumb to, manage to control the UI. But what you get in the end is, and that's a pretty interesting part, is you get a sound card mapped, a sound card on your Raspberry Pi, on your Linux machine, mapped to the mobile phone. And then you start thinking a little bit, what could you actually do? And we have from David seen like his Soipa example, right? So Soipa as a desk phone client, right, also uses the sound card for you to capture and record the calls and then sending it off to somewhere. And you can actually do the same thing with your mobile phone without doing a mobile application for your mobile phone, right? Because you have a sound card on your Raspberry, and you can capture and inject audio. So why not just wiring up to OpenAI's real-time API, for instance, which in fact turns any mobile phone into a voice bot, right? Doesn't have to be OpenAI. It can be like Simwood as well if they provide an API. I don't know. But the way that works is, it's the same picture, but instead of, manually trying to play and record the audio, you just use the, for instance, PyAudio, like the Python audio API or package, right? And put the OpenAI Python SDK on top and communicate with OpenAI's real-time API, right? And if you're thinking like, you just do that, well, it's not as easy as that, but there's a readily available GitHub project out there that does exactly that, right? You can run it on any Linux machine that provides sound cards, right? And your, Ophono, Wire Plumber, Pipewire thing provides a sound card. So you can just run it. There's a script in there. You just you put your OpenAI API key in there, and then you can call your mobile phone, and the mobile phone will answer if you, automatically let the phone answer there. And then it will just, pipe all the input over to OpenAPI's real-time API, and whatever comes back from there is being injected back into the mobile phone, and you can, have your phone as a voice bot. And that's a pretty playful thing of, playing with these kind of scenarios. And that's my presentation. So I'm super happy to answer any questions. We also have a desk near the reception over there. So if you have any questions regarding test automation or regarding this particular mobile tests or anything in between, feel free to approach us. My colleagues Oliver and Richard are here as well. So happy to answer.
Okay. I see many questions. First team, then we have here, then I saw another hand and another. So quite a lot. So again, they have a desk, so we don't have to take all the questions here to.
We're leaving tomorrow at 3 or 4, so feel free to approach me whenever. But
okay,
bring it up.
So thanks for that. It's really interesting stuff. I'm wondering whether you can extend it even further and talk to a VoIP service rather than using a PSTN as on the phone. Can you talk to anything else that runs CallKit on an iPhone, for example?
What the Bluetooth connection does, it per se controls the native dialer, right? And whatever the native dialer then does, it's like you sitting there and pressing the buttons. It's kind of like the same. It's just a remote control way of doing the calls, right? What you cannot do with that is like remote controlling voice over IP application, if that was the question, or something like that, right? But whatever the phone uses as a radio connection or technology in order to do the mobile calls, it's being used there as well. It's like just another way of interacting with the phone and the phone stack.
Was here the next one? Oh, sorry.
Yes, thanks. We've been using also some mobile testing, but we mainly first tried with the Chan Mobile from Asterisk and then the GSM Open. What is your experience? Have you used this? And if yes, how this is better than that?
Some of our customers are using these kind of SIM boxes with the modems in there as well, right? And it has some pros and cons. One is like the pro is, it's kind of like you operate a SIP gateway, right? So you put it there, you can configure a SIP peering from your infrastructure to this gateway and then just send a SIP call and then it does like the conversion to GSM or LTE or 5G or whatever the box can do, right? So it's simple to handle. But the drawback of that is that it doesn't reflect real end user experience because the end users don't use these gateways. They use an Android phone, they use an iPhone, right? So there might be different kind of, implementations at play, and it might work on the SIM box, it might work on the iPhone, but not on the Pixel 9 or whatever, right?
For example, GSM. For example, GSM Open or the Chan Mobile, it also connects via Bluetooth to the device and uses the native dialer.
All right.
You can make out the calls and receive calls, and the good thing is with Asterisk and FreeSwitch, you have very good APIs where you can write a lot of different scenarios and tests to, even for example, voice over Wi-Fi, voice over GSM, or changing the networks, from 4G or 5G to the Wi-Fi and so on. So that
very interesting. Yeah.
Okay. There is no question anymore. Okay, last one here.
Yeah, thanks. Just a quick question. Have you looked on the implementing like more Android car or CarPlay protocol? Because from there you can get much more information, like looking at the car, that, for example, a strength signal and things like this means, or it's just proprietary and closed. Have you looked in this direction?
Not into this direction. What we are playing a little bit is also getting like software on the SIM card and doing network measurement there and sending it off from there. Like you get like the cell information and everything. Our approach really there was to do it or try to do it without any kind of software that you install on the phone. You just use a stock phone and you can use that. And as I said, the option is also to put like working with the mobile carriers and try to get like a SIM applet into the SIM and doing the network measurement there and then using like channels to send off this information in addition to the tests. Yeah, but there's nothing in between that we have tried yet, right?
Anyhow, amazing. Yeah, interesting solution that you found there to play with any phone. Yeah, so it's easier now to test any kind of device. Okay, so as said, they have a table. Just go around the registration desk on the right, like just in front of the entrance. They will be here today and most of the tomorrow, as said. And ask for demos, discuss with Sipfront. Andreas, again, thank you for being with the project for a long time, supporting it with coding, by supporting the event as well. Really big thanks.
Thank you.